Assalamualaikum and welcome back. We are still on level surface, but in this video I'm going to show you an example of level surface. Okay, let's look at this equation. This question, it says if W is equal to this, sketch the level surface of F for C equals -1, 0, 1 and 2. So here we are asked to sketch 1, 2, 3, 4 level curves, but I'm going to show you only one of them. I'm going to pick C or W equals 1. Okay, so we have this equation W equals f of x, y, z equals z minus square root of that. Okay, and we want to sketch the level surface of f for W equals 1. Okay, now when W equals 1, the equation will be reduced to 1 equals z minus square root of x squared plus y squared. I'm going to rearrange the equation so that we can recognize the equation. Okay, we can sketch the equation easier. So rewriting the equation, we get z equals 1 plus square root of x squared plus y squared. Okay, I'm going to put a box around this. So this is the equation that we want to sketch. Okay, this is the equation that we want to sketch. I know some of you can do this very quickly, but I'm going to show you step by step how to sketch this. The technique is similar to what we've done before. We have to look at a few views, view from above, from the front, and from the side. That means that we need to let z as a constant, x as a constant, and y as a constant. Now in the equation, you can see that we have a square root there, so usually we have to be careful. Alright, so when you see x squared plus y squared square root, then we know that the expression inside the square root must be larger than or equal to 0, otherwise the function is not defined. But when you look at the equation, the expression inside the square root, we have x squared, which will always be positive, plus y squared, which also always be positive. The least is 0, so this equation, this inequality here is always satisfied for any real number x and y. So in this case, x and y can be any real number. Okay, now let's look at z. For z, here we have z is 1 plus square root of this. Okay, we know from before that this expression here is always larger than or equal to 0, which means that z must be larger than or equal to 1, because z is equal to 1 plus a value that is larger than or equal to 0, which means the least possible value for z is 1. So z must be larger than or equal to 1. Okay, I'm going to put this here. Z must be larger than or equal to 1, and I'm going to put a red box around this because we will come back to that. Okay, so now we're going to get a few views from above, from the front, and from the side. Okay, so let's get the view from above. Usually we pick z equals 0, yeah? But we can't, because z must be larger than or equal to 1. So let's say we pick z equals 1, right? When z is 1, the equation here, the equation in the red box, will be reduced to 1 equals 1 plus x squared plus y squared. Rewriting this, we get square root of x squared plus y squared is 0. Do some mathematical manipulation, then we get that equation, and we know by now that this represents a point. So it's not really a curve, it's just a point. Okay, so the point happens to be at x0, y0. So when z is 1, remember z equals 1 is a horizontal plane. We only have a point on that plane, not a curve, but a point. Okay, now from a point, you can't tell much about the shape or the surface of our function. So we need another level curve. So we need to pick another value for z, which is not going to be a point. Okay, so remember z must be larger than or equal to 1, so why don't we pick 2? Okay, now when z is 2, replace it in this equation, we get 2 is equal to 1 plus square root of x squared plus y squared. Simplify this, we get equals 1, and then we want to get rid of the square root. we just square both sides, then we get an equation of a circle. Okay, equation of a circle. Let's sketch that circle. So it's going to be a circle of radius 1, centering at x0, y0. Okay, we have, oops, sorry. A circle of radius 1 centering at 0, 0. So, okay, so we have a circle of radius 1, where this is 1, negative 1, 1, and negative 1. Okay, so a circle and a dot and a point, that would be enough for our level curve. A view from above. Now we need a view from the front. Okay, let's say a front, we have x equals a constant. I'm going to pick 0, okay, because here x and y can be any real number, so let's pick 0. When x is 0, the equation now becomes z is equal to 1 plus square root of y squared. Okay. Alright, I'm gonna show you step by step here. I know some of you can do this very quickly. So rewriting the equation, we get this. Okay, now I want to get rid of that square root, so we need to square both sides. So we have z minus 1 squared on the left and y squared on the right. And then rewriting the equation. I'm doing this very slowly. I know some of you can do this very quickly. So rewriting that equation, we have that. And now I'm going to factor the equation. So we have z minus 1 minus y. That is one factor. Another one is z minus 1 plus y equals 0. So from the first factor, this one, we get z is equal to y plus 1. Okay. And from this equation, we get z is equal to negative y plus 1. And those are all equation of a straight line. Okay, we have two equations of straight lines. Okay, all right, so for straight lines, that is quite easy to do. Let's see here. So here we have, oops, hang on. We have straight line. All right, here we go. Y-axis, x-axis. Okay, bigger, longer. All right, let's sketch this line first. Okay, for that line, we need only two intersection points. All right, for straight line, we need two intersection points. When y is 0, z is 1. Okay, let's say that is 1. Okay. When z is 0, y must be negative 1. Okay, y must be negative 1. So it will go through those 2 points. Okay, all right, so we have this line here, straight line. Okay, now let's look at the next equation, this one. Okay, let's get the intersection points. When y is 0, again, it will go through the point z. It's going to be 1. Z is 0 when y is 1. So let's say this is 1. Okay, so we just connect the 2 points. So here we have, hang on. So we have this line, this straight line. Okay, so we have the two straight lines that looks like an X. Okay, before we commit to these two straight lines, remember from above here, Z is larger than or equal to 1, meaning that we don't take the whole two lines here. We're gonna delete some of them. So we only consider Z that is larger than 1. Okay, hang on. Let me... Okay, this is our y-axis. This is our z-axis. All right, so we only consider the one part. We only consider z that is larger than 1. So this part is not included. and this part is not included as well. So the shape of our surface looking from the front is a V shape, more or less. Okay, all right, now that is a view from the front. I think from the view from the front and the view from above, two views from above, we can roughly say the shape of our surface now, but I'm gonna do it all the way. Okay, so I'm showing you step by step here. Okay, now let's look at the view from the side. That is when y is a constant. I'm going to choose 0 because here x and y can be any real number. So I'm going to pick 0. So when y is 0, our equation now will be reduced to, remember this is the equation that we want to sketch. Okay, so replacing y with 0, we get z is equal to 1 plus square root of x squared. Okay, some of you can do this very quickly. Rewriting the equation like so. Okay, square both sides so that we can get rid of the square root. Okay, and then rewriting the equation. I'm doing this step at a time, guys, so some of you can do this very quickly. And then factor the equation, we get z minus 1 minus x. That is one factor. Another one is z minus 1 plus x. That is one factor. From the first factor, we get z is equal to x plus 1. From the second factor, we get negative x plus 1. So those two represents two straight lines. Okay, so let's sketch this. It's going to be two straight lines. For the first line, so this is going to be on the xz plane. Okay, for the first line here, we need 2 points. When x is 0, z is 1, so let's say that is 1. And z is 0 when x is equal to negative 1, so let's say that is negative 1. So we have, we just connect the 2 points. Okay, so here we get this straight line. Oh, I'm going to change color, sorry. Right, so we have this straight line here. Okay, whoops, it's ugly. Alright, so we have one straight line. Now let's look at another equation. For the next equation here, we need 2 points as well. When x is 0, z is 1, so it will go through this point. And then z is 0 when x is 1, so let's say that is 1. Okay, and then we just connect the 2 points to get our trace. Okay, here we have, oops, straight line. Okay, so we have two straight lines and the shape looks like an X. Okay, similar argument that we used before. Remember, z must be larger than or equal to 1. Same thing here, z must be larger than or equal to 1. So we're going to delete some of them, but so we're going to only consider the one where z is larger than or equal to 1. Okay, so now we have the view from above, two views from above, a point on z equals 1 plane, a circle when z equals 2, and from the front we get a V shape, and from the side we get a V shape as well. So now we're going to put them together. Okay, I'm going to use a different picture. So we know that it's going to be a circle, oh, sorry, a cone. What am I talking about? Okay, so here we have x, y, z space. This is y, x, and z. Remember, we plot two level curves. One is for z equals 1, and another is for z equals 2. So let's say that's a 2. Okay. When z equals 1, we only have a point. Okay. And then when z equals 2, we have a circle of radius 1. Okay, so let's say this is a 1. Oops. Right, this is a 1, a 1, a 1. So we have a circle. But of course, if you pick another value of z, you get a circle as well, but the radius is bigger. And then the view from the side, when x is 0, we get a V shape. Okay, so we have a V shape, like so. Okay, and from the side, we have a V shape as well, like so. And of course, you can sketch this bigger size. I mean, you can go further up, like this one. Okay, you can make it bigger. So you can see that this is a cone. So this is for w equals 1. Okay, this is for w equals 1. But let's say we have w equals 0. For w equals 0, let's look at the equation again. For w equals 0, then our equation would be z equals this. Okay, z equals square root of x squared plus y squared. If you do the same technique as I've shown you before, this is also a cone, but the vertex of the cone is at 0, 0. So your cone might look like this. Okay, so it will be something like that. Okay, well, you can go further up if you like. So this would be when w is equal to 0. And I think for w equals 2 and also for w equals -1, I'm sure you can figure it out. It will be a cone as well, but you just have to shift a bit. All right, so the green one is for w equals 0. The red is for w equals 1. For w equals 2 and w equals -1, you have a cone as well. So the level surface for the function would be a cone. It's just that the position is a little bit different. But the technique of sketching the level surface would be the same as the technique of sketching equation with 3 variables. You need 3 views from above, from the front, and from the side. Okay, how am I doing with time? Oh, that's a bit long. Okay, that's all. Thank you.